For millennia, we have looked up at the night sky and asked the simplest, yet most terrifying questions. Where do we come from? How did it all begin? And, perhaps most profoundly, are we alone in the dark? Our eyes have always been limited by the light they can see. Even our greatest instruments could only peer so far through the cosmic dust before the universe drew a veil over its deepest secrets. Until now. To see the unseen, humanity had to build the impossible. The James Webb Space Telescope was not merely an upgrade from its predecessor, Hubble. It was a complete reimagining of how we observe reality. Hubble saw the universe primarily in visible light, the same light our eyes can see. But the oldest light in the universe has been traveling for so long through space that is constantly expanding that its wavelengths have stretched. They have shifted beyond the visible spectrum into the invisible realm of the infrared. To capture this ancient, invisible light, Webb needed to be an entirely different kind of beast. It took 3 decades, $10 billion, and the combined genius of thousands of scientists across the globe. At its heart lies the primary mirror, 21 feet across, composed of beryllium, a metal lighter than aluminum, but vastly stronger. These mirrors were machined to such flawless precision that if they were scaled up to the size of the United States, the highest mountain and the deepest valley would vary by only a few inches. And then, they were coated in microscopic layers of pure, reflective gold. But a telescope of this immense size could never fit into a rocket. The solution? Origami. Webb was designed to fold upon itself, a compacted marvel of engineering waiting to bloom in the vacuum of space. But before it could open its golden eye, it had to survive a journey that terrified the brightest minds on Earth. Leaving Earth was only the beginning. Webb's destination was not a low Earth orbit like Hubble. To detect the incredibly faint heat signatures of distant galaxies, the telescope itself had to be unimaginably cold. It had to be placed far away from the heat of the Earth, the Moon, and the Sun. Its home would be Lagrange Point 2, a gravitationally stable parking spot 1 million miles away in the dark ocean of space. A place where no astronaut could ever reach it to fix a mistake. The journey took 29 days. It was dubbed 29 Days on the Edge. For Webb to function, it had to execute an intricate, automated choreography of deployment. There were 344 single points of failure. If one pin failed to pull, if one cable snapped, if one motor jammed, the $10 billion dream would become space junk. The tension was agonizing. The sun shield, designed to protect the delicate instruments from the sun's radiation, had to unfold flawlessly. The temperature difference it created is mind-boggling. On the sun-facing side, water would instantly boil. On the dark side, it is cold enough to freeze nitrogen solid. Against all odds, step by agonizing step, the golden flower bloomed. Webb had arrived. It was time to open its eyes. When the first images finally beamed back to Earth, a collective gasp echoed through the scientific community. Because Webb sees in infrared, it acts like cosmic X-ray vision. The dense clouds of dust and gas that act as curtains in visible light become entirely transparent. For the first time, we were looking inside the stellar nurseries where stars and planets are actually born. We saw jets of gas shooting from infant stars, carving out massive caves in the surrounding nebula. We saw the delicate, intricate lattice work of dust holding together galaxies millions of light years away. It was as if humanity had been looking at the universe through frosted glass for our entire existence, and someone had finally wiped the window clean. But the true power of Webb was not just in looking through the dust, it was in looking through time. In this tiny patch of sky, an area no larger than a grain of sand held at arm's length, Webb revealed thousands of galaxies. The light from the foreground cluster left its stars 4.6 billion years ago, around the time our own Earth was forming. But the warped, distorted streaks of red light behind them? That was something entirely different. The curiosity of astronomers was about to turn into absolute shock. As Webb peered deeper into the darkness, it began to see the universe in its infancy. Light has a speed limit. When we look at a galaxy 10 billion light-years away, we are seeing it as it existed 10 billion years ago. Webb was built to look back further than ever before, to the cosmic dawn, the era when the very first stars ignited and ended the dark ages of the universe. The models of how the universe evolved told a very specific story. The earliest galaxies should be small, messy, and chaotic, taking billions of years to slowly clump together into massive structures like our Milky Way. But Webb found something that shattered those models. It found universe breakers. Webb detected galaxies existing just a few hundred million years after the Big Bang that were fully formed, incredibly massive, and blindingly bright. According to the laws of physics as we understood them, there simply hadn't been enough time in the universe for these gigantic galaxies to form. It was like digging in a prehistoric archaeological site and finding a fully functional smartphone next to a dinosaur bone. How could supermassive black holes and giant galaxies exist in the dawn of time? Webb didn't just give us answers. It handed us a terrifying and exhilarating new mystery. We do not understand how our universe grew up. As we wrestle with the ghosts of the deep past, Webb is simultaneously hunting for something much closer and arguably much more profound. It is listening for the whispers of life. Before Webb, we knew exoplanets existed, but they were just shadows, brief dips in starlight as a planet passed in front of its host star. Webb, however, possesses an instrument capable of an extraordinary trick called transmission spectroscopy. As a planet crosses its star, a tiny fraction of that starlight filters through the planet's atmosphere before reaching Webb's golden mirrors. Different molecules in the alien air absorb different wavelengths of light. By reading the missing light, Webb can tell us exactly what an alien atmosphere is made of. The discoveries have been breathtaking. Webb has definitively detected carbon dioxide on worlds outside our solar system. It has found water vapor churning in the skies of distant gas giants. But the excitement reached a fever pitch when it analyzed a planet named K2-18b, a Hycean world entirely covered in a global ocean beneath a hydrogen-rich atmosphere. Webb detected carbon-bearing molecules like methane, but hidden within the data was a faint, tantalizing signal of something else: dimethyl sulfide, or DMS. On Earth, DMS is produced by only one thing: life, specifically marine phytoplankton. While the detection on K2-18b is incredibly faint and requires more observation to confirm, the implication is staggering. We are no longer guessing what is out there. We are actively reading the chemistry of alien skies, inching closer every day to the ultimate paradigm shift, finding the first biological signature of life beyond Earth. The further Webb looks, the more the fabric of reality seems to fray at the edges. It is discovering things that belong in science fiction. In the Orion Nebula, Webb found jumbos, Jupiter mass binary objects. These are giant planets floating freely through deep space without a star to orbit, and inexplicably, they are traveling in pairs. Our theories of planetary formation say this should be impossible. Yet, there they are, wandering the dark. But perhaps the most profound mystery Webb is illuminating involves the very fate of the cosmos. For decades, scientists have been locked in a fierce debate over a crisis known as the Hubble tension. The universe is expanding, but depending on how you measure it, it seems to be expanding at two different speeds. Some hoped that Webb's unprecedented precision would finally resolve this discrepancy, proving one measurement right and the other wrong. Instead, Webb did the exact opposite. Its razor-sharp observations of pulsating stars and distant galaxies confirmed that both sets of measurements are correct. The universe is expanding faster than it should be, and we do not know why. It suggests that something fundamental is missing from our understanding of reality. Is it a new type of dark energy? Is it a flaw in our understanding of gravity? Are there forces in the cosmos that we haven't even begun to comprehend? The James Webb Space Telescope was built to answer our oldest questions, but its true legacy is entirely different. It is showing us that the universe is far stranger, more ancient, more complex, and infinitely more mysterious than our wildest imaginations. It has opened a new golden eye in the dark, and we have only just begun to look.